Hello and welcome. Have you ever stopped to think about how massive cloud services, the ones that run our entire digital lives, handle millions of requests at once without just collapsing? Well, today we're pulling back the curtain on the secret sauce, the global scheduling algorithm. This thing is the powerful brain that keeps these colossal systems from turning into total chaos. Let's jump right in. I mean, just try to wrap your head around it for a second. We're talking thousands of tasks, maybe millions, all hitting hundreds or thousands of computers at the same time. It sounds like a logistical nightmare, right? The key to taming all this complexity, to bringing order to the madness, lies in a single, incredibly powerful component that acts like the system's central nervous system. It's the one making all the critical decisions. And here it is. Meet the global scheduler. The best way to think about it is like the super strict, no-nonsense principal of a huge digital university. Its students, millions of tasks. Its job, to take this chaotic mess of incoming work and turn it into a perfectly orchestrated symphony of computation. It makes sure every single resource is being used to its fullest and that no task gets left behind. So what does it actually do? Well, the global scheduling algorithm basically holds the ultimate authority. It's constantly looking at the entire system, every single processor, every single task, and it makes the big calls. Who gets to run, where they get to run, and for how long. And the end goals are super clear. Crank up the performance, make sure every user gets a fair shot, and squeeze every last drop of efficiency out of the hardware. Okay, so what separates a good scheduler from a truly great one? It all comes down to a set of 10 golden rules. These are the core principles that every elite scheduling algorithm has to live by. Think of this as our principles' official rulebook. Let's break them down. First step, and this is a big one, load balancing. This is pretty much the foundation of any efficient system. The scheduler acts like a master delegator, spreading the workload as evenly as possible across all the available processors. Our principal would never bury one student under a mountain of homework while others have nothing to do, right? Same idea here. It prevents any single processor from becoming a bottleneck and slowing everyone else down. Next, we've got scalability. See, systems are always changing, always growing. A top-tier scheduler has to keep up. It has to maintain its awesome performance whether the system has 10 computers or 10,000. Back to our college analogy, the principal's rules have to work just as well for a small campus as they do for a giant, sprawling university. Performance can't just take a nosedive when things get bigger. That's not an option. But what happens when things break? And trust me, they will. That brings us to fault tolerance. Hardware fails, it's just a fact of life in these big systems. A really robust scheduler knows this is coming. It anticipates it, instantly detects when a machine goes down, and reassigns its tasks to healthy ones without missing a beat. Just like our principal has a substitute teacher on standby, the system has to keep running smoothly so that the users don't even notice a problem. Now let's talk about stability. This one might sound a little weird at first, but constantly shuffling tasks around to get that perfect balance can actually be a bad thing. All that moving around creates its own chaos and uses up resources. A stable scheduler knows when to just leave things alone. Our principal gets it. Constantly rearranging the classrooms in the middle of a lecture would cause way more harm than good. This one is absolutely critical. Low overhead. Look, the process of making the scheduling decisions can't be more expensive than the tasks it's scheduling. The algorithm has to be lean, mean, and fast. If it takes you 2 seconds to schedule a 1-second task, you're literally going backwards. Our principal believes in efficient administration that doesn't get in the way of the actual learning. Rule number 6 is all about fairness. In a system with tons of different users, you just can't let one person's jobs hog all the resources, leaving everyone else's tasks to starve. The scheduler has to be an impartial referee, making sure every process gets its fair share of the processing pie. Our principal makes sure every single student has equal access to the library, the labs, and the teacher's attention. Beyond just being fair, we need speed, which brings us to response time. See, not all tasks are created equal. Interactive stuff, like you clicking a button on a website, needs an immediate answer. A smart scheduler knows this and prioritizes those tasks to give you that snappy, responsive feel. In the same way, our principal knows that urgent questions from students need to be answered right away. So, while response time is about how fast one thing happens, throughput is about the total productivity of the whole system. The goal is simple: get as many tasks as possible done within a certain amount of time. This is really the ultimate report card for the system's efficiency. For our principal, this is like making sure the maximum amount of the syllabus gets covered during the school year. The digital world is always in motion, which leads us straight to adaptability. Workloads can suddenly spike, network conditions can get worse in an instant. A truly great scheduler is like a chameleon. It senses these changes and immediately adjusts its strategy to keep performance high. Our principal has to be nimble enough to reschedule exams if a freak snowstorm hits, right? Same principle. And finally, our 10th rule, minimal communication cost. To make all these smart decisions, schedulers need to talk to each other. But too much chatter clogs up the network and slows everything down for everyone. An elegant scheduler is a master of efficiency. It makes the smartest choices with the least amount of back and forth. Our principal avoids flooding everyone's inbox with useless emails, so the important announcements actually get read. Okay, wow, that was a lot. We just went through the 10 essential features. Knowing them is one thing, but being able to recall them when you're staring at an exam paper, that's another beast entirely. So how are you going to lock all this in for exam day? Don't you worry, we've got some powerful memory hacks coming right up. First up, we have the sentence trick. I want you to burn this phrase into your brain. Lazy students fear studying late for real tough assignments Monday. I know, it sounds a little silly, but it's pure gold. The first letter of each word maps directly to one of our 10 features. L for lazy is load balancing, S for students is scalability, you get the idea. It's a simple but shockingly effective way to remember the list. Now, if you want something even more compact, something you can just scribble down in a second, try the one-word code LSFLFRTAM. I know, it looks like a cat just walked across your keyboard, but try breaking it down into sounds, like a secret password. Lucif, Slif, Rutam. Say it out loud. Lucif, Slif, Rutam. See? It's kind of catchy, and it'll stick in your head. And for those of you who want to unlock your final form, we present the Anime Power Mode. Your ultimate technique is LSFLFRTAM. I want you to channel your energy into 3 powerful attack forms. Form 1, the Azure Aura, LSF, for load balancing, scalability, and fault tolerance. Form 2, the Crimson Aura, SLF, for stability, low overhead, and fairness. And for your ultimate move, the Cosmic Mode, RTAM, for response time, throughput, adaptability, and minimal communication. And here is your activation mantra. I want you to internalize these words. Ready? Balance, expand, protect, calm, fast, fair, instant, maximum, adapt, silent. Each word is the very essence of one of our rules. Just meditate on this for a minute, and you will have these 10 features completely on lockdown. All right, let's bring it all together now. We're going to consolidate everything we just learned into one final, crystal clear summary. This is your go-to slide for that last-minute cram session before the big exam. So, let's recap one last time. The 10 pillars of an amazing global scheduling algorithm are load balancing, scalability, fault tolerance, stability, low overhead, fairness, good response time, high throughput, adaptability, and, of course, minimal communication cost. If you can master these, you've mastered the core of this entire topic. And I'll leave you with one final and really crucial question. In the real world, you can't have it all. Perfection is impossible. It's always about trade-offs. You might have to sacrifice a little stability to get better load balancing, or maybe accept higher overhead to get rock-solid fault tolerance. So if you were designing a new system from scratch, which 2 of these features would be your absolute non-negotiables, and what would you be willing to give up to get them? It's a tough question, and it's one that every single system designer has to answer. Thanks for joining us for this explainer.